Hi students, this is Sahana Yasmin here. Welcome to tuition. In this video we have to discuss about exercise 1.3 chapter number 1 how to solve. This is the question number 3 part 3 in exercise 1.2. Find the inverse of this matrix by using Gauss-Jordan method. So in previous video we have find the Gauss-Jordan method, finding a inverse value. Similarly for this one we have using A matrices and identity for finding A inverse by using Gauss-Jordan method. So A is this matrix, so I put here 1 2 3 2 5 3 1 0 8. Put identity 1 0 0 0 1 0 0 0 1. So this is finding A inverse. For this 1, for this I get 0, I convert this into 0 also, because this is convert into identity matrix. So first one is put at itself, but second one and third one is convert into 0 because we get identity here. So second row, third row only changes. So R2 gives R2 minus 2 R1. Similarly R3 gives R3 minus R1. So I get 0 for this and this numbers. So first row it's not any change, 0 0. R2 minus 2 R1. So this entire row is multiplied with 2 and R2 minus 2 R1. So R2 2 minus 2, that is 0. 5 minus 10, that is minus 5. 5 minus 4. 5 minus 4, that is plus 1. 3 minus 6, that is minus 3. Then 0 minus 2, that is minus 2. 1 minus 0, that is 1. 0 minus 0, that is 0. Then third row I get formula R3 minus R1. So directly I minus this two numbers. 1 minus 1 is 0. 0 minus 2, that is minus 2 here. Then 8 minus 3, that is 5 here. Then 0 minus 1, that is minus 1. 0 minus 0, that is 0. Then 1 minus 0, that is 1. So I get this columns are 1 0 0 identity matrix. Then for this one I get 1 here and 0 0 for here. So I convert this into zeros. So R1 and R3 will be changes. R1 gives R1 minus 2 R2. Similarly R3 gives R3 minus, sorry, we are get a minus symbol, so I added this, minus 2 R plus 2 R2. So R1 changes, R1 minus 2 R2. So R2 is multiplied with 2. R1 minus 1 minus 0 is 1. 2 minus 2, that is 0. 3 minus of minus, that is 3 plus 6, that is 9. 9. Then 1 minus of minus 4, that is 1 plus 4, that is 5. 0 minus 2, that is minus 2. 0 minus 0, that is 0. Then second row is any changes, is not any changes, minus 3. So minus 3, minus 2, 1, 0. Then R3 gives R3 plus 2R2. R3 is this plus 2R2. Multiply with 2. So 0 minus 0 is 0. I put 0 here. Then minus 2 plus 2, that is 0. Then 5 minus 10, that is 5 plus of 2 minus 6. 5 minus 6, that is minus 1 here. Then minus 1 minus 4, that is minus 5. Then 0 plus 2, that is 2. Then 1 plus 0, that is 1. 1 plus 0 is 1. So I get these values. So second column is also get the identity. I create identity this matrices. So I get this and this correctly 1. Then finally this also changes into 0, 0, 1. So I change this minus 1 becomes plus 1. So I can put R3 gives R3 divided by minus 1. So I get 1095 minus 2 0, 0 1 minus 3 minus 2 1 0. Then R3 is 0 0 plus 1 plus 5 minus 2 minus 1, because I divided the R3 by minus 1. So I get this. From this I convert these two numbers or zeros, because the identity matrix is completed. So R1 gives R1 minus 9 times of R3. Then R2 is also changes. R2 minus, I get the minus value, so I can add it. So R2 plus 3 times of R3. So I get 1095 minus 20. First row is also changes. 9 is cancelled by this number. So R1 minus 9 times of R3. So R3 is multiplied with 9. R1 minus this. So 1 minus 0 is 1. 0 minus 0 is also 0. 9 minus 9, that is 0. 5 minus 45, that is minus 40. It's 44 here. Minus 2 minus of minus 18, that is plus 18. Minus 2 plus 18 I get, that is plus 16. So plus 16 here. Then 0 minus 9, 0 plus 9, because I have already 1 minus symbol here. So 0 minus 9, so that is plus 9. Then second row is not any changes. 0 1 minus 3 minus 2 1 0. Third row is also second row is also changes. Third row is not changes. 0 0 1 5 minus 2 minus 1. Minus 2 minus 1. Second row changes is R2 plus 3 times of R3. So R2 plus 3 times of R3. 0 minus 0 is 0. 1 plus 3 into 0 is 0. So 1 plus 0 is 1. Then minus 3 plus 3, that is 0. Minus 2, 3 times of this, 15. 15 minus 2. 15 minus 2 is 13. Then 1 minus 6, that is minus 5. Minus 5 here. Then 0 minus of minus 3, that is 0 plus 3. So I get minus 3 here. Then so I get minus 3 here. So I get the identity value. So this is the A inverse value. So I get A inverse minus 40. A inverse is equal to minus 40, 16, and 9. Then 13 minus 5 minus 3. 13 minus 5 minus 3. Then 5 minus 2 minus 1. This is the A inverse value by using Gauss-Jordan method. I hope you all understand this problem. We are moved to 1.3, exercise 1.3, problem number 1. So first question is, solve the following system of linear equations by using matrices of inversion method. So this inversion method is very simple one. So first one is 2x plus 5y equal to minus 2. Then x plus 2y equal to minus 3. This is the question number 1. From this we have take the coefficients of x and y, that is the A matrices 2, 5, 1, 2. This is A matrices into xy is equal to minus 2 minus 3. So this is like Ax is equal to V. So we want x value only. So x is equal to A inverse B. So we have to find A inverse. I using the simple method of finding A inverse value, that is 1 by A is this is value, evaluated value 2 into 2 is 4 minus 5. 4 minus 5 into these two numbers are interchanges 2, 2. Then these two numbers are put minus symbols, minus 5, minus 1. This is the A inverse value. So 1 divided by minus 1 into 2 minus 5 minus 1, 2. This is the A inverse. For x we have to find A inverse into B also. So B value is this is. So I can put this into A inverse. So we can multiply row and first column. 1 divided by minus 1 into minus 4 plus 15. Similarly second row first column. Minus 1 into minus 2, that is plus 2. 2 into minus 3 is minus 6. So this value is x is equal to minus sign here. Minus 4 plus 15, that is value for this minus 15 minus 4, that is 11. Minus 4 for here because the big number having minus symbol. So I can put this minus into inner value. So x y is equal to minus 11 and 4 for this. So I get x is equal to minus 11 and y is equal to 4. So I verify this equation number 1. X and y values are substituted in equation number 1. Equation number 1 is 2x plus 5y is equal to minus 2. 2 into x value is minus 11 plus 5 into y value is 4. I get minus 2 for this equation. So minus 22 plus 20, this is equal to minus 2. So right hand side and left hand side get values are equal. So hence the x and y values are proved. Similarly, second part is also having two equations. From this we have get the coefficient of x and y taken as a matrix 2 minus 1 3 2 is equal into xy is equal to 8 minus 2. This is like A, this is like X, this is like B. So I want X value, so A inverse into B. So A inverse is I created the simple format finding A inverse, that is 1 by determinant value 2 into 2 4 plus 3, that is 4 plus 3, because I have minus 3 but evaluated value is also having some minus 1 minus, so the minus into minus is plus, so plus 3 into, I can interchange these values 2 to 2, I can interchange these signs, minus 1 is get plus 1, this is minus 3. This is the finding A inverse value 1 divided by 7 into 2 1 minus 3 2 into B value for X. B is this number 8 minus 2. So I can multiply first row and first column 1 divided by 7 into 16 minus 2, then minus 24 minus 4. I get 1 divided by 7 into 16 minus 2 is 14 minus 28 for here. So I can put this into inner values. So x is equal to 2 times minus 4 times. So x value is this, y value is this. X is equal to 2, I get y is equal to minus 4. So I verify this by using first equation. First equation 2x minus y is equal to 8. I'll put x value and y value here. That is 2 into 2 minus y value is minus 4 is equal to 8. 4 plus 4, that is 8. So the left hand side is also 8, right hand side. So hence we can prove the x and y value from equation number 1. So this is the xy value. I hope you are all understand this problem. Similarly, the question number 3, third part is also having coefficients values taken as a matrices. Then we can multiply it with x, y, z equal to 9 minus 1. This is the third part question. I directly converted it into matrices. A x is equal to b. So we get x value A inverse into B. So A inverse, we have to find the A inverse value for this. So A is equal to 2 3 minus 1 1 1 1 3 minus 1 minus 1. So for this we have to find A inverse value. A inverse is equal to 1 by determinant of A into adjoint A. So first we have to find the determinant of A value. Determinant of A is equal to 2 into corresponding row and columns are get cancelled, minus 1 plus 1, that is 0. So can put 0 here. Minus 3 because the coefficient values are plus minus plus. So I put minus 3 here. Minus 3 into corresponding row and columns are get cancelled. Minus 1 minus 3, that is minus 4. Minus 4. Then similarly third one, minus 1 into corresponding row and columns are get cancelled. Minus 1 minus 3, that is minus 4. So minus into minus plus 12, then plus 4, that is 16. 16 is not equal to 0. Therefore A inverse is exist. So we have to find the adjoint value for finding A inverse. So adjoint of A is finding from minor value. Minor is, for this A matrices is minor value, we get the corresponding row and columns are get cancelled. I put A here also because that simplify easing, we get the minor value. 2 3 minus 1 1 1 1, 3 minus 1 minus 1. So from this I get the minor value. M is equal to the corresponding row and columns are get cancelled. Minus 1 plus 1, that is 0 for here. Minus 1, the corresponding row and columns are get cancelled for second one. 1 into minus 1 is minus 1. Minus 3, minus 1 minus 3, that is minus 4. Third one, the corresponding row and columns are get cancelled. Minus 1 minus 3, that is also minus 4. So similarly the corresponding row and columns are get cancelled. Minus 3 minus 1, that is minus 4 for here. Then the corresponding row and columns are get cancelled. Minus 2 plus 3, that is 1 plus 1. Then the corresponding row and columns are get cancelled. Minus 2 minus 9, minus 2 minus 9, that is minus 11. Then the corresponding row and columns are get cancelled. 3 plus 1, because I have already one minus, the evaluation having one minus, so minus into minus is plus. So 3 plus 1, that is 4. Then plus 4, then the corresponding row and columns are get cancelled. 2 minus of minus 1, that is 2 plus 1, so that is 3. I put 3 here. Then the corresponding row and columns are get cancelled. 2 minus 3, that is minus 1 here. 3 minus 1 here. So this is the minor value. From this cofactors we have to find easily. Plus minus plus, minus plus minus, plus minus plus. I put this signs into minor value, I get cofactor. So 0 minus minus plus 4. So plus 4, plus into minus is minus 4. So minus 4 here. Minus into minus is plus, so plus 4 here. Then plus 1, minus into minus, that is plus 11. Then plus 4, minus 3, minus 1. So this is the value for cofactor. We have to find the adjoint value, that is nothing but the cofactor transpose. 0, first column is taken as a first row. 0 4 0 4 4. Then second column is taken as second row. 4 1 minus 3. Then similarly third column is taken as a third third row. Minus 4, 11, minus 1. This is the adjoint value. We get the a determinant value and also a adjoint value. So we have to find A inverse by the value of A determinant and adjoint value. Adjoint is this. So we have to put A inverse is equal to 1 by determinant of A is 16. We get 16. Then the adjoint value is 0, 4, 4. 0, 4, 4, 4, 1 minus 3. Then third row is minus 4, 11, minus 4, 11, minus 1. So this is the A inverse value. So x is equal to A inverse into B. So we have already B value. So we can multiply these numbers. 0, 4, 4, 4, 1 minus 3, minus 4, 11, minus 1 into B values, the right hand side value 9, 9 minus 1. So we can multiply these numbers, first row and first column, that is 1 by 16 into 0 plus 9 into 4 is 36, minus 1 into 4 is minus 4. So this is the first row. Second row, similarly, first column multiplication. 4 into 9 is 36. 1 into 9 is 9. So plus 9. 36 plus 9. Minus 3 into minus 1, that is plus 3. Then similarly third row with first column. It is minus 36 plus 99 plus 1. So hence we can evaluate these values. 36 minus 4, that is 32. Then this adding these values we get 48. Then we solve this, we get 64 here. So this 16 is divided by this matrix, we get the value like 2, 3 times, 4 times. So x is equal to 2 from this, y is equal to 3 from this, z equal to 4. So we get x, y, z, but we can prove this is right or wrong by using first equation. First equation is 2x plus 3y minus z is equal to 9. So 2 into x value is 2 plus 3 into y value is also 3 minus z value is 4. So minus 4 is equal to 9. 4 plus 9 minus 4 is equal to 9. Plus 4 minus 4 get cancelled, then 9 is equal to 9. So left hand side and right hand side are equal. So the x, y, z values are proved. I hope you all understand this problem. Go to next one. The fourth problem is also having one matrix. I take the coefficients of x, y, z, that is the A matrix. So A matrix into x is equal to B. This is B. So means we can find x is equal to A inverse into B. So A inverse formula is 1 by determinant of A into adjoint of A. So we have to find first determinant of A. So that is A determinant is equal to first one. So 1 into corresponding row and columns are get cancelled, balance are evaluated. Minus 8 minus 10. Minus 8 minus 10. Then similarly this having minus 1. So minus 1 into the corresponding row and columns are get cancelled, balance are evaluated. 6 into 12 minus 10. 12 minus 10, that is 12. corresponding row and columns are 12 minus 25, 12 minus 25, then plus 1 into corresponding row and columns are get cancelled, 12 minus of minus, so 12 plus 20, 12 plus 20. So this is the number 1 into minus 18 minus 1 into 25 minus 12 is get minus 13, then plus 1 into 32. I can simplify these numbers. Minus 18 plus 13 plus 32. We get plus 32. We get these numbers 27. I get 27 for a determinant value. We have to find adjoint value. So A is equal to 1 1 1, 6 minus 4 5, 5 2 2. From this we have to find the adjoint value. So first we have to find minor value for this matrix. Corresponding row and columns are get cancelled. Minus 8 minus 10, that is minus 8 minus 10 is minus 18, then the corresponding row and columns are get cancelled. 12 minus 25, that is 12 minus 13, 25. This minus 13 for here, then 12 minus third one 12 minus of minus 20, that is 12 plus 20, this 32 here. Then the corresponding row and columns are get cancelled. 2 minus 2, that is 0. This is similarly this corresponding row and columns are get cancelled. 2 minus 5, that is minus 3. Similarly the corresponding row and columns are get cancelled. 2 minus 5, I get minus 3. Here also minus 3. And similarly this corresponding row and columns are get cancelled. 5 minus of minus 4, that is 5 plus 4, that is 9. Then similarly the corresponding row and columns are get cancelled. 5 minus 6, that is minus 1. I get minus 1 here. Then the corresponding row and columns are get cancelled. Minus 4 minus 6, that is minus 10. 10 here. So from this we have to find the cofactor value, that is this is nothing but the plus minus plus minus plus minus plus minus plus. We have put this sign into this minor value, we get the cofactor. So minus 18 minus into minus, that is plus 13 plus 32 minus 0, that is 0, minus 3, then minus of minus, that is plus 3, so we get plus 3 here, then plus 9, minus into minus, that is plus 1 here, minus 10. So this is the cofactor value. From this we have to find the adjoint value. Adjoint of A is equal to the first column taken as a first row, so minus 18 0 9. Second column taken as a second row, 13 minus 3 1. Third column taken as a third row, 32 3 minus 10. This is the adjoint value. We get a determinant value is 27 and adjoint value is this. So we have to easily find A inverse value. A inverse is equal to So A inverse is equal to 1 by determinant of A is 27 into minus 18 0 9 and 13 minus 3 1. This is the adjoint value. I put adjoint value here. Then we have to find x is equal to A inverse B formula. So A inverse is this. So A inverse is equal to 1 by 27 into minus 18, 0, 9, 13 minus 3, 1, 32, 3 minus 10 into B value was we have already see in question 2, 31, 3. This is the B value, right hand side value. So we have to multiply the first row with first column. 1 by 27 into minus 36 plus 0 into anything is 0 plus 9 into 3 is 27. Wait a minute. This is the value of 13. So 9 into 13 is, it is plus 117. So similarly second row and second column. 13 into 2. 13 into 2 is 26 minus 3 into 31, that is minus 93 here. Then 1 into 13, that is 13 plus 13 here. Similarly third row and first column, that is 32 into 2, that is 64 plus 3 into 31, it is 93 plus 93 here, minus 10 into 13, that is minus 130 here. So we can solve this matrix. 1 by 27 into first row we get 81, second row we get minus 54, third row we get 27. So I taken into this matrices. So 27 inside, going to inside we get 3 minus 2, 2 time, 1 time. So this is the x, y, z values. So x is equal to 3, y equal to minus 2, z equal to 1. Hence we can verify by using equation number 1. Equation number 1 is x plus y plus z is equal to 2. This is the equation number 1. So we can put x value, y value, z values. So 3 plus 2 plus 1. Sorry, we have y value is minus 2. So y is minus 2 here. So 3 minus 2 plus 1 is equal to 2. So 3 minus 2 is 1. 1 plus 1 is equal to 2. So 2 is equal to 2. Left hand side and right hand side we can get same value. Hence we can prove the x, y, z values. Thank you for watching this video. I hope you all understand these problems. We can move to next one.